Welcome again, everyone. Felix and Bill. I think we can just dive right into talking about quality management. And as I mentioned earlier, quality management is just such a huge and integral part of engineering management, and it associates with design, manufacturing. Why is quality management such an important piece of what we do in both in the manufacturing and the service industries? And it's not that quality management is a new phenomenon to any of us, but in some ways it has remained the same, and in some ways it has changed significantly. So, with that, Bill, I'd like to start by asking you that how have you seen quality management change over the last several decades? You've been in aerospace for over 3 decades, and how have you seen quality management so from a pre-21st century to a 21st century transformation, if you may call it, or lack of thereof?
Well, thanks, Jimmy. Yeah, I would say I didn't look into any of this until I started working at Connecticut. Just became fascinated with it. And first to say that if you think about quality management, a great portion of what we call quality management goes back to the concept of manufacturing known as interchangeable parts, and the shift in manufacturing from craftsmanship, where I made everything and put it all together. I could have bought some stuff, but it largely was done by a craftsman putting it all together. And then in the early 1700s, the 18th century, that changed, and we went to this concept of interchangeable parts. And then Henry Ford went off and ran with it. But prior to that, a lot of the early running was done by Eli Whitney, and that's when we moved from one person doing everything to everyone having their own component. And I'll just say the essence of looking at things as parts, and each part, judging a part as being a good part or a bad part, has been part of quality management, since the advent of interchangeable parts. And so a given part today, designed by someone like Felix, has a bunch of characteristics: length, width, lengths, dimensions, and whatnot. And each of those requirements has not a fixed length. Felix doesn't call out it must be an inch long. Felix will call out that it has to be an inch plus or minus something, and that's to allow for variation. So instead of the oven temperature being 500 degrees for an hour, it might be called out to be 500 plus or minus for an hour, plus or minus a few minutes. And then quality, alive and well today, is looking at each of those temperatures, dimensions, and saying, is it within requirements? And that's pretty much where we are 300 years later. And the thing I would say is what's changed in the last 50 to 100 years is very subtle, yet very significant. And again, this is all new to me. It comes from an introduction to what I refer to as contextual excellence as opposed to compliance excellence. Compliance excellence is asking, is this a good part or not? Yes, there's only two answers, yes or no. Is a characteristic of a dimension, does it meet the requirements, yes or no? A guy by the name of Walter Schuhart, a mentor of Dr. Deming back in the 1920s, started looking at variation in how requirements are met. And looking at that variation gets us into the realm of what I look at as, and for nice conversation, contextual excellence. And this is something I started talking about at Rocketdyne, learned from Dr. Taguchi, advanced by Deming and others. And then that became part of training that Felix got exposed to. And Felix and a few others ran and did some mighty things with it.
You mentioned two terms. So you mentioned compliance excellence and contextual excellence, right? Just to kind of explain those two terms a little more in depth for the audience, could you explain those with an example? That
Yeah,
what
well,
would
let
an
me give you a,
example of compliance excellence be versus an example of contextual excellence?
Sure. Let me explain it in terms of everyday compliance excellence in sports. Is the soccer ball in the net? Yes or no? Is the baseball thrown by a pitcher, judged by the umpire, who's the quality inspector, and the umpire says that's a strike or that's a ball? And what's a strike? It means it's somewhere in this box known as the strike zone. And so quality management in terms of compliance excellence is asking, is the ball in the net? Yes or no? Is the soccer ball, is the baseball within the strike zone? Yes or no? Black or white? Contextual excellence is about where's the ball within the strike zone? Does it matter? And traditional quality is about it doesn't matter where the ball is in the strike zone. And you don't get to be a professional pitcher in baseball without realizing that sometimes it matters where you place the ball. And again, there could be a batter that can't hit the ball no matter where it is. That's me. And there could be another batter, Otani, who plays now for the Dodgers. He knows where the ball is in the strike zone. So if I'm pitching to him, I've got to be very precise in where I locate it. Well, that's that's about me as the pitcher trying to get the ball around him, not just anywhere in the strike zone. And what Felix was able to do is take these ideas and realize there's aspects of a design where it matters where the hole is within the requirement. So if Felix is designing a product with a hole, sometimes it doesn't matter if the hole is anywhere within the requirements. Sometimes it matters, he wants the dimension to be really precise, just as the pitcher wants the dimension to be precise. And it's because of what there could be a tube going into the hole, and that may have a precise outer diameter. And what we're talking about with compliance excellence is it doesn't matter where you are in the strike zone. It doesn't matter where the hole is, where the outer diameter is. And what Felix made great use of is the appreciation we both gained from Dr. Taguchi, who visited Rocketdyne a few times, is that there may be situations where it really mattered. And then our challenge became, how do we convey that in a system which is largely compliance excellence, right, Felix?
Right. It's absolutely true. The intriguing aspect of all of this is that I was taking courses from Bill for about 5 years before we started RS-68, maybe even 10.
Felix, can you just clarify for the audience, just in a sentence, RS-68, so everybody's clear?
Right. RS-68 is the engine on the Delta IV rocket. So it's, if you looked at we were supposed to have a launch of the heavy Delta IV Heavy, there are 3 RS-68 engines on the bottom. So these are the largest liquid oxygen, liquid hydrogen engines that are manufactured in the world. So there's about 675 pounds of thrust, liquid hydrogen, liquid oxygen. And what Bill came up to me one day and I told him what I was doing, and he goes, "What?" He had no idea. It came as a complete surprise to him. So it was really intriguing to him that I had actually taken his theory and put it into practice. And then we made great strides into doing that. So that was the big gain that we made on implementing the theory into practice, employing Dr. Deming and Dr. Taguchi's methods, plus some of Russ Akoff's comments too. So it was all about moving quality and understanding how we're going to design quality for this product, which was a rocket engine called the RS-68.
Thank you, Felix. So I guess just to kind of sum up, right, between compliance excellence and contextual excellence. So in compliance excellence, it's more of a binary, right? Yes or no, requirements met, requirements not met. And whereas from a contextual excellence, you're considering the entire system and trying to understand how your part actually fits in and integrates with the system. Would you say that that is a fair summation of the difference between the two?
Jimmy, let me add an example that Felix is well aware of, which builds upon what you just said. If I'm at home in the garage working on a woodworking project, it takes a number of pieces of wood and puts them all together. What I do at home, where I cut the pieces of wood and I do assembly, nail it together, glue it together, is, I measure out the length that I want, 1 inch, 1 foot, 15 inches. And I draw a line that says this exactly 1 foot. And then I cut exactly to that line as close as I can. And then I do that for the other pieces. And the reason I'm focusing on that single line as close to it is that makes it easy for those pieces to come together. Now, when I go to work, if I'm in a work setting, then Felix will call out a design and it'll say 12 inches plus or minus a 1/16 of an inch. And all of a sudden we get into this idea of tolerances. And so at home, I'm precise. I'm making it exactly 12 inches because contextually, I know that that piece is part of a set of shelves that I'm making. At work, I'm cutting a piece of wood and Felix calls out a length. And then I go into the mode of it's got to be 12 inches plus or minus a 16th. And I've lost track of what this is part of. I'm just focusing on the part in isolation. And what Felix and I began to realize is wait a minute, there's situations at work where being close to that 12 inches might really matter. I do that at home. Does our system at work allow me to shift from a compliance excellence mindset at work? And because now I'm talking with Felix as a manufacturing person, I realize, holy cow, Felix, and this is what we try to convey with coworkers is let's take the thinking at home where we're looking at that piece of wood as part of an overall system. And there's situations where we want to bring that thinking into work where I'm cutting the piece of wood, but I'm paying attention to the context in which it is used. And just like I'm being careful as to where I am in the strike zone, I am being very careful as to where I am within the tolerance range that Felix gave me. And we found that there are designs that it really matters. So the big thing is, Jimmy, I'll just say is there's a place for contextual excellence and there's a place for compliance excellence. But most training and most practices you'll find that I found around the world today are compliance excellence.
Right.
Got it. Yeah.
And what
Thank you.
was exciting is in the courses I do at Southern Utah for Cal State Northridge, I am presenting examples that have been cleared. And a good number of these examples were designs done by Felix, produced by other colleagues in volume. And we've
Right.
never seen anyone talk about anything like this anywhere.
Yeah. Thank you. I really appreciate that clarification. And it's so important, right? Even when you're a supplier for your customer, understanding this difference between compliance excellence and contextual excellence.
Right.
Right. Because a lot of times as a supplier, Bill, you mentioned the example at home, as a supplier, you may not have that bigger picture from your customer, that where does your part really fit in and how does it integrate, not just fit, but how does it integrate into the larger system?
So imagine Felix is doing the design work. We're both working with manufacturing people that are working inside, some working outside. And it wasn't uncommon for them. What we did is we gave them a little piece of wood from the woodworking I was doing in our garage at home with our son. And on that little piece of wood, it could have been like 4 or 5 inches long, 1 inch wide by an inch. On there was a squiggly line that our son had drawn when I was doing woodworking. And literally, Jimmy, our manufacturing engineers were going to suppliers with this little piece of wood saying, that dimension, that Felix is calling out, that's like the one line at home. We want you to aim for that one line. And we couldn't do what we did without the ability to communicate that. I mean, so we had to have an internal communication mechanism within the organization and then simple ways of explaining it to suppliers without which we could not have had the success we had over the life of the program.
Right.
And this
Yeah.
wasn't just a one-time deal. We put
No,
this in
this is
place and outsourced lots of this to people that had to maintain this focus, and they did.
right.
Yeah. Thank you both.
Yeah.
So Felix, I'm going to now transition to you with our second question, that how has this change, right, or this transition over time that Bill talked about affected the design and manufacturing of products as well as the overall system? Because we've been talking about, the piece, how does it integrate in the overall system?
Right.
So share some of your thoughts about how it's affected the design and the manufacturing, which the overall system.
The one of the things that's intriguing about this is, and I gave a presentation in Bill's InThinking conference for several years, and the problem is, how do you confine the system? Where do you break the edge of the system? Bill always gave the example, if you wanted to bake an apple pie, how do you start? And then Carl Sagan said, well, first you start with the universe. So the thing that's intriguing about where we're at now I found that if I just brought in my manufacturing and my quality and myself into the product design of anything, I was leaving out inspection. I was leaving out purchasing. I was leaving out a myriad of things that were going on with the product that were part of what the quality of the final part was. And once I realized that, I realized, oh, these people are important because these parts, some of the parts are fragile. So if I don't define in the purchase order how to ship the part so that it arrives, intact and ready to assemble, that's a huge miss on my part and on the team's part. So you have to think about where you're at in the entire system to do something. So the biggest thing that I find for me is trying to get people from the contextual quality to understand how to hit targets. And the easiest way for them to understand that is the language of CPK. So I tell them, the first thing I'm looking for, well, do you guys do a run charts? Do you understand what your process control is? Do you understand how well you can control your product? And it's intriguing because a lot of manufacturers don't have systems and they don't have guardrails on how they design or build something. Well, they think they know how to build it, but they don't actually do the same thing every time. We had this metal seal that was being formed for us. And when we went up there, we noticed the technicians were using different settings to actually create the part. And it rolled the part differently for each one. So we would have a seal on one seal, but we wouldn't have a seal on the other because the part wasn't perpendicular to where the seal groove was. And understanding that phenomenon of how things work and how things go together, even inside their component to us, we had a component. If you've ever gone to Home Depot or anything and you need a locking fastener, and you'll see some of them will have a little dot and some of them have a little strip. We had a very important and critical part that used Vespel, which is quite capable of working at cryogenic temperatures. And this plastic is very expensive. So, but the problem is that in the manufacturer's house, the slot that the plastic went into and the width of the slot were not controlled as an assembly. They weren't thinking about it. So they were creating a lot of parts that weren't capable. They weren't. And once we introduced them to CPK and understanding how to manage their variation, that manager came back to me and says, Felix, we're making money hand over fist because we don't have nearly the scrap rate on that very expensive Vespel that we did previously. And that's the thing that you find, that what happens when everybody starts understanding what their process and what their process control capability is, that they start minimizing their scrap and they increase their profits and they increase their schedule times, or they minimize their schedule times. Those are the things that you look for. So,
and those would be some of the impacts, right, that you see on the quality due to these changes that you just mentioned.
Right. Yeah, exactly. I mean, it's just simple things, but as we say, if you think about the whole assembly and the whole part, it's everything that works really well.
So you mentioned one term, Felix, you said parts that were not capable, right? And when you say parts that were not capable, are you referring to from an integration perspective, or can you expand a little bit on that?
Well, so the way that it works is you have a slot and you have a piece that goes inside of it. So the width of the slot would be too wide, or the piece, the plastic that went inside would be too thick and it wouldn't fit. You didn't have the proper compression that you needed between these two parts, or these two features, so to speak. So that's what was going on. So they'd put a part together, but it would come apart immediately, or they couldn't make it work. So that was the whole idea. So the whole idea was to, once they understood that they had control of their processes, then they minimized their scrap, their schedule rates moved to the left, everything started running smoothly. And like I said, they were excited about how much more profit they were making because they weren't generating scrap.
Yeah. Thank you, Felix. Appreciate that clarification. So I'll kind of go back to Bill now. Bill, you started off by talking about the compliance excellence and then contextual excellence. But in your opinion, Bill, what are some of the primary concepts or important concepts and strategies, as well as tools and techniques, right, in quality management that you would advise people to focus on?
All right. Well, let me say, teaching in the CSUN's MSAM program, I cover a number of concepts because I like to give people a broad perspective that there are a lot of concepts out there, such as Lean, Six Sigma, operational excellence, Dr. Deming's work. So there's, so what is a concept? And because I want to differentiate concepts and strategies from tools and techniques. So first, a concept is an abstract idea, a fundamental building block of thoughts. It could be zero defect quality. It could be Dr. Deming's system of profound knowledge. Examples of quality management, in addition to those, Six Sigma quality, Lean, all right? And a given concept has a strategy. So within Rocketdyne, Felix and I were there many years together, and we had a strategy as to how to deploy this within Rocketdyne. And we did our best. We had a strategy on how to deploy it across the organization, including our suppliers, including our customers, including the greater community. So we had intensive classes on these ideas that we opened to the public as a strategy to, in part, have coworkers become more excited about what we're doing because we've got people from around the world coming to see what we are doing. So what is a tool? A control chart is a tool. A cell phone's a tool. A ruler is a tool. Gauges are tools. So garden shovel's a tool. Tools are the implements used to complete tasks. Techniques are how we go about that. And there's lots of tools in quality management. And I spent the first couple of years at Rocketdyne. A lot of the training I was doing was tools and techniques, tools and techniques. And the challenge was it was being utilized within a mindset of compliance excellence. And the challenge became we needed more than tools and techniques. And so we're not against tools and techniques. Tools and techniques, to borrow from Russ Akoff, are about efficiency, doing things fast, doing things cheaply, but they don't answer the question why. And so we needed to focus on contextual excellence, which is a word language we developed within Rocketdyne, coming largely from Dr. Deming and Akoff. And so our strategy was we wanted to have tools and techniques, but used with a great sense of why that was otherwise missing, because we were given flow downs from the Air Force on contracts that were challenging a compliance excellence mindset. I mean, we're given compliance excellence goals that couldn't be met if we stuck within that mindset. So we needed to step back and realize a lot of the constraints we had were driven by a compliance mindset. We needed to shift to a contextual mindset. And so that's what I would say is, but what fascinates me about Deming's work, in particular, Dr. Deming, is thinking that, again, he didn't use the term contextual excellence, but he's talking about systems in a way that others didn't. He's talking about variation in a way others didn't. He's talking about, the ability to inspire people in an integrated way. And so what we started to do is, at least what I started to do, is shift a lot of the training I was doing from tools and techniques. Tools and techniques are great. We didn't get rid of it, but we had to expand to get into concepts and strategies. MSc course that I teach cover a broad range of concepts and strategies and tools and techniques. So that's what I would say, Jimmy.
Thanks, Bill. I know that you have a very, well, let's call it a interesting view on Lean Six Sigma. So I guess the mantra of Six Sigma is to reduce variation. And if you look at the Lean, it's like, okay, reduce waste, right? And Six Sigma is reduce variation. So, and you made a key point when you were talking, you said tools don't answer the why, right?
Right.
So can you tell me, when you talk about managing variation versus reducing variation, right? Are they both the same? Or are they different from one another? And how are they different, if so?
Well, that's a good question. Once upon a time, I used to talk about reducing variation. Then I saw the light. Well, what I started realizing is the word reduce preceding cost, reduce You could talk about reducing cost, reducing inventory, reducing waste. And then you'll see that associated with let's drive, not only do we want to reduce, but we want to drive to zero. And to me, driving anything to zero implies that what you're dealing with is bad. So we want to drive cycle time to zero. We want to drive waste to zero. Well, have you ever seen a skinny whale? The lean folks will talk about, waste and you have to get rid of the fat. Well, whales have fat for a reason. I mean, people that personally try to get rid of body fat end up in trouble. So instead of focusing on zero as the goal, part of managing variation is not that we want zero, which you couldn't have anyway. There's no such thing as identical twins. And what's missing in this, with Six Sigma quality, there's many aspects I don't like. Now, I cover it in the course to be able to give people a sense of why I think it conflicts with what Dr. Deming is talking about. So one is, if you want to drive variation to zero, what I would ask is, how much are we going to spend to do that? And what you don't see in Six Sigma quality is an explanation of the cost. And then in terms of the benefit is to achieve 3.4 defects per million. Well, a defect is something which is not in the strike zone. And so if you look at Six Sigma quality and that basis, we're saying two things. I want to drive variation to zero. We aren't talking about cost. And fundamentally, it's a compliance excellent mindset. So nothing in Six Sigma is about where the balls are in the strike zone. And so part of the managing variation is we want to have the appropriate amount of variation, the appropriate amount of cost, the appropriate amount of cycle time. And my concern is when we're driving that to zero in a work setting, we're likely not thinking about who's using this, nor the cost of doing it.
Yeah.
Right. And then Bill had a great example of why you needed variation, because we had these blades that we were putting on a rotor for a turbo pump. And the manufacturing engineer was really excited about the class, and he got all of the blades to be the same width. And when they went to assemble the turbine blade, there was always a gap, because previously the variation in the width allowed them to stack the turbine so there would be an acceptable gap. So think about that. If you were trying to control the width of a blade plus the diameter of a hub, right? So you're looking at controlling those two aspects of something, whereas if you just let the width of the blade float a little bit so that you can actually achieve, a proper gap when it's all assembled, and you're not increasing cost. See, that's the other aspect of what Bill's talking about, is that where do you want to apply zero deviation? And from my experience, anytime I'm dealing with a hoop and I'm trying to put parts inside of it, I need to actually expand my variation per part so that I can actually make the part fit with the proper gap. If everything is the same, I can't control the variation as the hoop grows or constricts so that I can actually fill the part adequately and properly.
Makes sense. Thank you, Felix. So I'll pose a similar question to you, Felix, that in your role, right, as a design engineer, what training did you receive in college about these concepts and strategies, as well as tools and techniques that you're talking about, right? And what sort of things should we be focusing on as we train the next generation of quality management professionals or engineering managers?
So you have to appreciate the fact that I graduated in 1985. So that's a long time ago. And there weren't any classes in quality back then, not to my knowledge. I mean, we barely got into CFD and finite element analysis. I mean, those were the beginning stages of education back then. Everything I learned was on the job for relative to quality. The biggest things that I learned about how making parts work was actually working on a human-powered vehicle for the ASME chapter. And we learned how to put parts together, how to make things fit, how to work together as a team, and looking how to make things correct for the first time, right? It's that whole garage shop mentality of drawing one line and getting everything, cutting everything to fit the first time, which is craftsman mentality. It's not production mentality. When you get into production mentality, you're thinking about tolerances. And when you're thinking about tolerances, it's a lot different. The one thing I can tell you for a student is you have to learn ASME Y14.5, which is geometric dimensioning and tolerancy. That's the one thing that as a student, I would tell you, you need to understand that document if you're going to be a design engineer or you're going to be a manufacturing engineer, or if you want to try to understand quality. The only document that you have to control parts is the drawing. And the drawing is defined by GD&T, ASME Y14.5. So if you don't understand that document, it's trying for me to speak to you in German when I don't know German. You have to understand the language, and you have to understand how to speak it and understand it. And the thing you have to appreciate sometimes is that the people that you're talking to don't understand the language as well. So one of the things that happened when we were creating this RS-68 engine is the mechanics didn't understand the language of Y14.5 as well as the engineers. So we had to dumb down the language so that they understood and we got what we wanted. That was part of the issue of working with them and understanding what their needs were. Even though it was correct, the English was correct or the language correct, they didn't understand it. And if they don't understand it, they're going to make mistakes. So that was the whole point of that. So understanding what they did, that's really a big improvement. Just the whole idea of getting people in a room and talking about what they're doing, how they're doing it, what do they need? That's a big improvement on trying to get things. But as far as schoolwork for the undergraduate, taking a CAD class or trying to get to me Y14.5 GD&T, geometric dimension tolerancing, those would be my biggest go-tos for someone that's trying to actually build things in a production environment.
Thanks, Felix. And what about the gap between design and manufacturing, right? Can you talk to us a little bit about that, right? Because your role was primarily as a design engineer. So besides some of the things that you just mentioned, what were some of the other primary things that stood out to you as this gaps between design and manufacturing that sort of presented challenges or prevented from a smooth handoff, so to speak?
Yeah, the part of the problem with manufacturing right now as a designer is that the industry is moving very fast. It's moving faster than I can actually tell them how to actually design things. Currently, we have the capability to start on one end with copper and on this end up with stainless steel. And it's a monolith. And there's no way to describe that in any CAD package currently. You can't do it. There's no way to say how you're going to do that. We have additive manufacturing, which we didn't have 20 years ago. We have high-speed machining like we didn't have. There's carbide tools that cut with incredible precision and incredibly fast. But the thing that I found that for me, what was the best thing to do was just to go to the trade shows, the manufacturing trade shows, find out what was available, find out what was happening, see what was going on. Because that's when I would see, oh, I can apply this to this design. This works out better for this application than not. So it's really tough to stay on top of manufacturing. That's the hard part. And myself and another fellow engineer for RS-68, we took a world manufacturing course from Long Beach State. And that was very instrumental in us being able to devise methodologies for designing. So like one of the things that I mentioned and it became very impactful was the fact that the fastest way to remove material from an object is drilling or turning. So if you looked at our designs for the RS-68, the vast majority of those parts were turned, which became really important when we burned one up the first time and we had to rebuild it in under a year. So it was really important that our manufacturing engineer could just put it on the lathe and just take huge bites out of that ingot and just have the part become into shape really quickly. if we were milling it or doing any other kind of process, we never would have won the contract. It's one of those things that happens. So it's just understanding that.
Gotcha.
So
thanks, Felix. I appreciate you sharing those thoughts. So, Bill, we also hear these terms in quality about zero defect quality, right? And snap fit quality. What's your thought about those, and how do they relate to, to the compliance excellence and the contextual excellence terms that you've introduced us to earlier?
Sure. Compliance excellence is what zero defects is all about. I want all strikes and no balls. Or Six Sigma quality, I'll take 3.4 defects per million. So compliance excellence is I want everything to meet requirements, again, without an appreciation that it matters where we are within the requirements. And again, there may be situations for a design that Felix has that anywhere within is okay. And how do you know that? And a question I ask students is, what do you call the person that graduates last in their class in medical school? And what's cool about that question is everywhere I do seminars live or online in the world, literally around the world, people can relate to that question. Now, I can't talk about baseball when depending on where I go. And depending on where I go, if I say football, they think I mean American football. And I'm saying no. So, but anyway, ask people, what do you call the person who graduates last in their class of medical school? Everyone says doctor. Then I say, well, is there a difference between the first in class doctor and the last in class doctor? And if there is a difference, when does that difference appear? What people typically talk about is, who worked harder to get, and I'm looking not at the past, how they got there. What I point out is the difference between any two things that meet requirements shows up in use. So when those two doctors walk into my room and they interact with me, with my family, with the other physicians, that then is a sense of contextual excellence. And the better they fit, Jimmy, the better they come together hand in glove is snap fit, is a term we used at Rocketdyne called snap fit. So snap fit is when you're paying really close attention to how we meet requirements of the respective parts so that they go together easily. Because if you don't pay attention, you may bang them together. And Ford had a term I came across. There was in a Ford factory years ago, back in the 60s, the general manager is where I got the term snap fit. And he said, most of the time when they put the parts together in these Ford products, they banged them together with rubber mallets. And every once in a while, two parts went together without a mallet, and they called that snap fit. Well, I would say, given all the random variation, now and then two parts went together, but most of the times it was mallets. And when this general manager went out and bought products made by competitors, they assembled just like theirs, mostly hammers. And then they went off and bought a Toyota pickup truck in the late 60s as an experiment, because their idea was buy competitors' cars, take them apart, put them together. Well, all that hammering is compliance excellence. And when they discovered that the Toyota pickup truck was 100% snap fit, they realized that where you are within requirements, I say that was at Rocketdyne, we use that as inspiration that there's times when it matters. And so inspired by that late 60s example and a couple others, we did things with it at Rocketdyne in the 90s that, again, I've never had anyone come up to me and say, Bill, what you're talking about, we practice where I used to work. No. So Felix and I are excited to share this with you together as to the differentiation. Compliance excellence gives you hammers, perhaps. Maybe hammers is okay. Maybe it's not worth the trouble to do more than that. Contextual excellence uniquely gives you the ability to deliver snap fit if you think it's worth the effort.
Right.
So would you both say, Bill and Felix, that snap fit quality ties in with is necessary if you want to do a good job at systems integration?
Oh, absolutely. I would say,
because that's such a huge part of what we do, right? Because a lot of manufacturers are assembling subsystems and integrating subsystems to put them together, or integrating systems to create a larger system of systems.
Felix and I could tell you stories. Part of the challenge is, and what I discovered in organizations is the people doing development. Again, I never did any of it. I mean, I did some development work when I worked in rocket engines in Connecticut. That was a very, it wasn't anywhere near what Felix and other colleagues have done. But I'll give credit to in development, people understand how well things come together on that concept engine they're building, which starts off on paper, and they're paying attention to, if I make this thinner, then I do this. They understand integration. In development, people understand integration. But what I would tell the systems people at Rocketdyne, but here's, because they say, Bill, we understand integration. I said, well, you understand integration, but you don't understand variation. You're not designing for variation. You're designing as if every dimension that Felix wants will be achieved. So what I would say to them is, in the world of development, we don't see variation. And what I would also tell them is, as soon as the design is done, then it moves to people that are all about compliance excellence. So even if it's designed with a sense of integration, as soon as the design is done and it goes to a production environment, now we're back to compliance excellence reigning the day. And what's missing is we don't know how much we're missing in that transition. And this is what we try to get across to people is what you see in systems is not the real world of variation, and it's not the real world of conformance to requirements. And what we had to get across to them is how much performance are we losing because we're not paying attention to compliance? Because if you're stuck in the world of compliance excellence, you may be losing a lot of performance and paying a whole lot for hammers that the systems people in development don't think about.
Right. So a couple of stories. The RS-68 injector that Bill and I worked on, the hole tolerance is plus or minus 0.4. The post diameter is a tolerance of plus or minus 0.4. We went to an outside vendor and we told them that we wanted the injector, which had over 600 holes, to maintain that tolerance and
Felix,
only use.
That's 0.4 of a thousandth.
0.4 of a thousandth.
Right.
Right. 0.4 of a thousandth.
So it's
0.0004. And we only wanted them to use 30% of that bandwidth. Okay. So we went to a vendor and we told them that we wanted to do that back in the 90s. And this was a very world-class manufacturing engineers. They had certified manufacturing technologists, and they told us point blank, you can't do that. And we said, oh, really? We've done it twice. And then they thought about that and they realized, ooh, maybe we're doing something, maybe they have something for us. The other thing is that what Bill is talking about, if you allow the variation to be haphazard, or if you control it, we had an instance where we noticed, not myself, but another engineer, John Geddes by name, he noticed that the post inside of the cylinder was not concentric. And he thought, I wonder what would happen if I made them concentric. And I made a little tool that would take all of like a minute or 20 seconds or so to bend it into shape. Well, he went ahead and did that, and he improved the performance of the engine by, I think, like 5 seconds of ISP. Now, what you don't appreciate that, and it's kind of a unique term, but for a second of ISP, a program manager would kill their dog. Literally, it is a huge, huge improvement. And to gain 3 to 5 seconds of ISP just for, 2 minutes worth of work, literally, that's what we're talking about. This is, once you get into this mindset of understanding how variation impacts the whole system, and then you're thinking about it, you're going, wow, this is incredible. So
yeah, what somebody once said to me once is it's about every product, there are gaps, there are clearances of how things come together. And so this guy said, so it's about the gaps between the tube and the hole, the gaps between this and how they come together. I said, it's all about the gaps. He says, well, how do you know which ones are important? I said, that's the secret sauce. And what Felix and coworkers did is they systematically experimented and started to play with gaps that we otherwise ignored, variation we're otherwise ignoring. And so we moved from compliance excellence to contextual excellence, and then started to say essentially, like, where in the strike zone should we be throwing the ball? Because now we're beginning to realize it might matter sometimes.
Mhm.
And as we discovered that, then the challenge was to, how do we not lose that when we go to the supplier? How do we get that into this program forever? And beyond that, how can we take that to other programs? And we shared
Right.
what we could publicly, but a lot of what we did, we couldn't share with anyone. Because once you
Yeah.
learn these aspects of where gaps matter, where they don't, you keep it to yourself.
Right. It becomes a trade secret.
Trade secrets.
So yeah. So and the other aspect of what Bill's alluding to is that the main injector for the RS-68, which is the product that we employed all of this information from Deming to Gucci, Russ Akoff, all of that information went into this product. This product's got, oh geez, about 3,000 parts. Money insignificant, but it's 3,000 parts. Over the life of the program, which is 20 years or so, the numbers of defects, nonconformances per part averaged 3. Several of them were 0 defect. And I found this out because I had left the program and I went and talked to my old manufacturing engineer, Mike Malinzek. And I asked Mike, I go, Mike, how's everything going? And he goes, Felix, I have no idea where the main injector is. It flies through the shop. The turbo pumps, I know exactly where they are because they always have problems. So the whole idea of this is trying to implement parts that fly through the shop, because you want, if it's not taking up time and you don't have, let me use a nasty term here, if you don't have quality dealing with it because it's generated a non-conformance or something that's out of tolerance, then, it moves on to the next step. So the whole idea is to minimize errors, minimize problems, and make the part flow through the shop. That's the whole idea. And I've managed to do that more than once. I did it also on another project called J2X, which in some ways even more astounding, because I raised the ISP on that, I think, like 25 seconds. But that was not unexpected, mainly due to the way that the geometry was. But I mean, there was a lot of things that I did that were novel and don't apply to quality, but apply to design engineering. That's a topic for another subject. But the whole idea is, if you think about your part as part of a system rather than just a part, right, then you get benefits that you don't normally get. That's the
But
whole
the
idea.
Absolutely.
but the other thing I want to add to what Felix just said, Jimmy, is what we're talking about is improving communication. And I can't tell you how much I learned about design from Felix and Mike to better understand what it is what I was trying to do and what they could do. So it's all about improving our ability to communicate and think together. Where Felix and Mike and others went, they took this with them from program to program. Others just looked at it, either one in disbelief because they had a hard time understanding, even within the organization. And so 10 years after the R68 is in production with all this success that Felix is talking about, I had a young engineer in my office with a bachelor's and master's from a big engineering school, very sharp guy. He was very excited. I saw him in a meeting. He was very excited, brought him by my office I wanted to talk with him about what Felix and others had done. And he says to me, I heard all that from Felix and Joe. He says, I don't buy it. And I thought, what do you mean? Well, within 10, 15 minutes, using a piece of wood, I was able to explain it to him. He didn't buy it. And so I thought that we were doing a pretty good job explaining it. And as good as we tried, and this is where these terms come from of compliance, excellence, contact, part of the role of this language, where the ball is in the strike zone, was how do we make this every day understood? And we'd find that people at all levels were saying, oh, all you're doing is tightening the tolerances. And we're like, no, even if the tolerance, Felix is talking about tolerances that are plus or minus 0.0001, 14, no matter how tight the tolerance is, it might still matter where you are. So, part of the role of talking about compliance versus contextual is minding the part, minding the gap, was trying to improve how we were conveying, because it was sometimes very hard, right? So Felix used to come by my office all the time, and I'd say, and we were much younger then, and I'd say to Felix as he'd walk by, I says, "So Felix, how are things going?" And Felix would say, "What, Bill? Or what, Felix?"
If I had a baseball bat, my arms would be tired from swinging, because it is really hard to move people when they don't understand. Or I think the thing that astounded me more than anything else is that when we first put one of the injectors together, all of the experts, and we're talking about people that like 100 years of experience doing brazing, told me point blank, Felix, it'll never braze on the first cycle. It never happens. It always takes 2 or 3. And we've accomplished that for 20 years. We've never had an issue with one single cycle braze on the RS-68 engine. So it's just one of these things that you're like going, I've given you proof, I've given you data. What more do you need, and how can I make this any simpler?
Yeah, what was amazing is, Jimmy, realize when we started, when I came to Rocketdyne, we had videos of what others were doing. We had explanations of what others were doing. And what we're trying to do is get our own results. And in my admiration for Felix and Mike and a few others is because they put into practice a bunch of ideas and turned it into hardware that was snap fit. And even then, people would deny it. And they would jump back to the best they could do to understand what we were doing is compliance excellence. And we're like, no, we didn't use compliance excellence, which is why we had to come up with terms to explain to them what we did was not traditional quality. What we did was we focused on a spot in the strike zone and said, aim here. And so much of the languaging was necessary to convey a vision we had and a result we achieved. And so, as exciting as it was to get the result, it was so hard to convey what it is we accomplished, because what people heard was compliance excellence. And what we were saying, what we thought we were saying, was contextual. What people heard, and this brings me to a dear friend, mentor to Felix and I, Gypsy Ranny, who used to visit with us on a number of occasions. She was a senior statistical advisor to General Motors, as brought into GM at Dr. Deming's encouragement. And she said, she asked Dr. Deming once, what do people get out of your seminars, Dr. Deming? And he told Gypsy, he says, I know what I said, I don't know what they heard. And Felix and I know what that's like. Well, the idea is that what we began to realize is what we said not only is not what they heard was compliance, and what we're trying to convey is contextual. So part of the languaging was to try to, we said, we're minding the gap, we're not minding the part. And anyway, all to say, we did some really exciting things. And I'm very fortunate to teach in this program, Jimmy, and convey what it is we did, where you're getting to meet Felix, who's amongst the leading designers and mentor of many within Rocketdyne and elsewhere, as to how this can be carried elsewhere.
Well, thank you, Bill and Felix. I really appreciate you sharing your expertise with the audience, and it's personally been such a great learning experience for me as well. I want to be respectful of everybody's time and open up the floor now to some questions from the audience, so that if anybody in the audience has questions, please feel free to raise your hands using the reactions tab, and I can call out to people as they have questions. I guess we're past our time, so everybody's this. I have one last closing question. Yeah, Tosin, go ahead.
Hello, everyone. As an engineer with more of a design background, what advice would you give them, being that their point of view has been more from the design and the more conceptual side? What advice or any sort of insight would you give as far as making that transition from design to quality management?
Felix, you want to take that?
You have to look at how quality is going to go through and do the inspections and verifications of what the product is. What you do as a designer, you design it, but you don't think about normally, unless you're doing minding the gap, so to speak, is how you're going to do the inspection. So one of the things that you're asking, okay, so I have a part, am I going to blue light it? Am I going to put it in a CMM? Am I going to use calipers? How am I going to inspect it? Does it have a sealing surface, or does it have special surface requirements? So all of these aspects that you're going through and figuring out, okay, this is what I'm defining on the drawing, but now the quality person has to go in and verify it and validate it. So you have to think, your mindset is more about being a judge rather than being a creator of how to do things. I think, does that answer your question?
Yes, I think that definitely answers and gives some insight to that. So thank you.
Okay.
Thank you, Felix. Mike, I think you have your hand up next.
Okay, Felix, Bill,
Yes.
great to see you both. Okay, my question is, and you've kind of hit on this a little bit, both of you. How do you shift that paradigm where people aren't thinking in terms of compliance so much? I mean, even our standards, our quality standards, are written on the basis of compliance. I don't see them making a new quality standard that is going to be referenced in a contract that says, okay, use this standard, and it's going to be a contextual type thing. Maybe too new a term, maybe too new a thinking, but how do you initiate that kind of thinking without somebody looking at you and rolling their eyes and saying, you're from the moon, Alice? There's no way that can work. Take a shot.
For me, the easiest way to do that is define a CPK on a drawing and say that, and Boeing has this great symbol called key characteristics, where you can define certain keys on a drawing and say the CPK has to be X, this one can be Y, this one could be Z. So you can say, okay, that I can easily convey to someone that this is how you're going to go forward. The other aspect of this happiness is that you're going to have to define in the drawing a specification that demarcates all of this information that you're trying to do, because it's not actually in the document. One of the things I found that blew me away in the anodized document is that it said, the temperature of the water is to be hot, okay? So how do you define hot, right? We're talking about an aerospace specification for anodizing aluminum, and it's saying hot. How do you justify that to anybody? So one of the things I would tell someone that is doing working quality is to go through and make sure that you quantify everything that you're trying to quantify. If it's not quantified, if it's just a qualitative description, it's not adequate, because you may or may not meet the mark of what you're trying to do for what the process you're trying to, the intended impact of the process that you're trying to control.
And you know what? I hear what you're saying. And for a Boeing, that's probably a great way to go. But there's a lot of mom and pop shops out there that are not going to be using SPC. They're not going to have nobody on staff that has that kind of strength. And when you start talking in these terms of I'm going to give you a CPK and you apply it, they're going to say, we don't make enough parts, so we don't have the repository to kind of generate that kind of look at the distribution, or however you want to put it. And it's not going to help them. So I'm just, like I say, to the mom and pop shops, which there are still a lot out there, how do you go and encourage them to say, take a walk on the wild side and look at things a little differently? I mean, take yourself out of your normal mindset and look at it differently.
I would ask them, when I hit somebody like that, a mom and pop shop, I go, well, how much scrap did you generate last quarter? How would you like to cut that in half?
Okay.
Or eliminate a majority of your scrap?
Okay.
Are you doing that? How is your repeat business? Metalex used to deliver cutters for diapers to the Middle East. And bottom line is that the person that received it said if it didn't have the Metalex logo on it, he wasn't going to accept it. He was going to put it into the ocean, because he says the ones that didn't come from Metalex didn't meet his requirements, and he ended up with more problems than they were worth. He says the Metalex ones, they would cut, and they would cut for, like, you know, the time that they wanted it to cut for, and then he knew that he could replace it. He says the ones that come from brand new from a different vendor, right off the bat, he had problems. One of the stories that we had with a vendor, he was having problems. A lot of these problems mom and pop shops do. And he found out about SPC and CPK and process control. And he figured out, I got nothing to lose. And he started to embrace that philosophy. And he realized, oh, I'm making schedule. I'm making less scrap. I could actually define my schedule, how much it's going to be. He won this important contract with Hughes aircraft helicopter because he knew he could actually make the part at the price they wanted. And it was a fantastic win for him. So that's the whole idea. The whole idea of your mom and pop shops are saying, you know, especially they're squeezed. If they understand their process, even if it's a single dimension, if they understand their process and start implementing it slowly, that's the whole idea. The whole idea is to understand your process so that you know you're going to make parts 100% to target. We didn't get into a lot of the things about variation and target thinking in this session, but it's one of the things that I find very intriguing about quality in between old Detroit and Japanese manufacturers. So
okay, very good. I like the idea of scrap. I think scrap is a good driver to get somebody to stop and take a look at how they're doing things, and maybe saying, hey, you only have so much money for this contract, and you can't even get it all bought because you didn't make it all right. So your scrap rate is so high. And I have had conversations with different small mom and pop shops, kind of trying to allude to that. But like I say, sometimes their expertise is limited. They're bringing in third-party people in there temporarily, and that rarely works out well.
no, I understand. And it's not a simple thing to do, but like I said, it's just one of those things that for me, in my position, working with a large corporation, I could always demand, you know, I need this to happen. I mean, one of the problems that I have with SpaceX is that one of their launch failures was due to the fact that one of their struts was made by somebody who made a strut, a carbon fiber strut, in their garage, and it went into a rocket engine and it failed in the middle of the launch. Okay, so that's their prerogative. They're willing to take those risks, but you know, that's the whole concept of process control may or may not be, you know, adequate for someone that does something in their garage. So
understood. Bill, you got anything to add to this?
I would say a couple of things, Mike. One is people change at a rate which is inversely proportional to the benefit they see. So the faster they see the benefit, the faster they change. And so if getting them to use physical process control is not working, it's because they haven't figured out that it's about making money. It's been sold to them in some convoluted way that hasn't broken through to a couple of things. One is, even at Rocketdyne, we had everybody collecting data, and nobody knows why other than we're collecting it. And that gave people a really bad taste in their mouth for collecting data. They're like, we're collecting it to collect it. And the strategy became compliance excellence is asking the question, has the requirement been met? Yes or no. Does the car have gas? Yes or no. That's pretty simple. And use that where that's all we need. Now, if it's important to know how much gas is in the car, well, then look at the gas gauge. That's what we do. So we wouldn't think at home driving our car without periodically looking at how much gas is in it, and whether that gas gauge is reading what's the pH level of the plating tank or what's the strength of the nickel. And that's what we're trying to say is if we monitor those things, then we might not lose the recipe for plating for a year. And so our strategy was to make it simple, that what we're doing is like what we're driving a car. You wouldn't think of having an idiot light for a gas gauge, right? And so that's what we found, is that it's sometimes you just have to just boil it down to economics. Now, another thing that helped us enormously in R68 was the Air Force came along in the mid 90s and put in place a requirement that every piece going into the entire rocket had to meet requirement. And what Felix and I and others did was convince the executives that we don't know how to do that without contextual excellence. And we got them to realize that if we're not monitoring where things are within the requirements, then you're just asking for trouble. And so the benefit we had that was enormously helpful was a requirement from the Air Force that could not be met with how we conducted business.
Right.
And that was, you can't ask for, and it was, and then the people in the Air Force who set that requirement on us came to work at Rocketdyne when they retired from the Air Force. We loved that they set the requirement. They loved that we had an incredible concept and strategy for how to achieve it. And the hardware Felix is talking about was amongst the pieces that were just show pieces within Rocketdyne, within Boeing, for what we're trying to do. It's about money at the end of the day.
Well, thank you again, Bill and Felix. I really appreciate your time. And to the audience, thank you for attending this session. I hope it was beneficial. And please do, we'll put this recording up. We'll share it with everybody. It was really insightful. Please do stay in touch, and we'll be continuing this series of webinars that we do related to engineering management. And I look forward to seeing you all attend some of the following webinars that we'll have in the coming months as well.
Yeah. And Jimmy, anybody that wants to reach out to me on LinkedIn, they're more than welcome to. And I'm always happy to answer questions.
Thank you, Felix. That's really very kind of you. We appreciate it.
Okay.
Thank you, Bill. And thank you, Heather. We appreciate you being here so late. And have a good evening, everybody.